All of you, welcome back. We are starting new chapter, gravitation. What is our chapter? Gravitation. So we are starting new chapter, gravitation. What is gravitation? Gravitation is the force of attraction between any two bodies in the universe. What is gravitation? Force of attraction between any two bodies in the universe. But what is the difference between gravity and gravitation? Gravity is the force of attraction between Earth and any object lying on the Earth's surface. What is gravity? It is the force of attraction between Earth and an object lying near to the Earth's surface. Acceleration, ACCE, acceleration produced in a freely falling body under the gravitational pull of the Earth is called what? Acceleration due to gravity. So what is gravitation? It is a force between any two bodies in the universe. What is gravity? If one of the bodies is Earth, or it is a force between Earth and an object lying near the Earth's surface, it is called gravity. Acceleration produced on a freely falling body under the gravitational pull of the Earth is called what? Acceleration due to gravity. Note here. എല്ലാവർക്കും good afternoon, good evening. ആരതി, ദിയ, അഭിഷേക്, സ്മൃതിലയ, വിസ്മയ, അഭിനവ്, നന്ദഗോപാൽ, ശ്രീശക്തി, അനില, സനുഷ, വിജുഷ, നന്ദന, ഹർഷ, അർജുൻ കൃഷ്ണ, എല്ലാവർക്കും ഗുഡ് ഈവനിങ്. എല്ലാവർക്കും ഗുഡ് ഈവനിങ്. നോട്ട് ചെയ്യടാ, വാട്ട് ഈസ് ദ ഡിഫറൻസ് ബിറ്റ്വീൻ ഗ്രാവിറ്റേഷൻ ആൻഡ് ഗ്രാവിറ്റി? നോട്ട് ചെയ്യട്ടാ. Good evening, Shada Nasrin. Good evening. Pradeep, Lakshman, good evening. നോട്ട് ചെയ്യാട്ടോ, നോട്ട് ചെയ്യുക. ഗ്രാവിറ്റേഷൻ, വാട്ട് ഈസ് ഇൻ മൈ ഗ്രാവിറ്റേഷൻ, വാട്ട് ഈസ് ഇൻ മൈ ഗ്രാവിറ്റി, വാട്ട് ഈസ് ഇൻ മൈ ആക്സിലറേഷൻ ഡ്യൂ ടു ഗ്രാവിറ്റി. Dia noted. What about others? Please note it. Those who have joined lately, we have started gravitation chapter. It is one of the easiest chapter, and it's very important also. You can expect some direct questions. Entrance also you can expect minimum one question. In some question paper you can expect two questions from gravitation. Two questions you can expect. Done, right? Yeah, next. Weight of a body. What is the weight of a body? Weight of a body is defined as the gravitational force with which a body is attracted towards the center of the earth. So what is weight of a body? It is the gravitational force with which a body is attracted towards the center of the earth. What is weight of a body? It is a gravitational force with which a body is attracted towards the center of the earth. Weight is a vector quantity. That is the reason why there is a W vector equal to mass into gravity vector. Suppose this is Earth and there is a mass m. It is attracted to the center of the Earth with acceleration due to gravity. So what is weight? Mass into gravity vector. Weight vector equal to mass into gravity vector. Weight is a vector quantity. It is measured in the unit of force such as Newton or kilogram weight. That is two units. One is Newton, other one is kilogram weight, etc. As the value of G varies from place to place. G is not a constant. Up to 10th standard, you will study that acceleration due to gravity is a constant. But in +1 physics, you should understand that G is not a constant. There is a slight variation in G. G varies from place to place. Weight of the body also varies from place to place. But mass of a body remains constant everywhere in the universe, which is a very important point. A body weighs, a body have mass 80 kilo on the surface of the earth. On the surface of earth. What will be the mass of body? What will be the mass of body at the center of earth? That is also what? 80 kilo. Why? Because mass remains the same everywhere in the universe. Mass remains the same everywhere in the universe. What varies from place to place? Weight. Why weight varies? Because weight equal to mass into gravity. Since gravity varies from place to place, weight also varies from place to place. But mass of a body remains constant everywhere in the universe. Mass of a body remains constant everywhere in the universe. Note data. Note data. Always remember, mass varies from place to place. Weight remains the same everywhere in the universe. Note ചെയ്താ. Next, Newton's law of gravitation. Every particle in the universe attracts every other particle with a force which is directly proportional to product of their masses and inversely proportional to what? Square of the distance between the masses. So first there is a particle of mass m1, then there is a particle of mass m2. The force between it is separated by distance r. Force between these two particles directly proportional to product of the masses, inversely proportional to square of the distance. So F directly proportional to m1 m2 by r square. F is equal to what? G m1 m2 by r square. What is G? Universal gravitational constant. Universal gravitational constant. Universal gravitational constant. What is the value of G? G is equal to Fr square by m1 m2. Fr square by m1 m2. Unit of G is what? Unit of G, kilogram meter square, not kilogram, it is force, right? Unit of G is Newton meter square per kilogram square. This is the unit of G. Any doubt? The value of G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. G യുടെ value. Any doubt? Note ചെയ്യാട്ടോ. Note ചെയ്യാം. Every body in the universe, every particle in the universe attracts every other particle. It can also be called inverse square law because distance is what? Square of distance is inversely proportional to force. So this is inverse square law. Square of distance inversely proportional to force. So this is also called what? Inverse square law. No data. നോട്ട് ചെയ്തോ? All of you done? Yeah. So continuing. So Newton's law of gravitation done. Now, if m1 equal to m2 equal to 1 and r equal to 1, m1 equal to m2 equal to 1 kilogram, r equal to 1 meter, then force is equal to what? Actually, universal gravitation constant. The universal gravitation constant may be defined as the force of attraction between two bodies of unit mass each and placed at a unit distance apart. So what is universal gravitation constant? It is defined as the force of attraction. Remember, gravitational force will be always attraction. Force of attraction between two bodies of unit mass separated by unit distance apart. Any doubt? Note here. Done. Universal gravitation constant may be defined as the force of attraction between two bodies of unit mass separated by unit distance apart. Done? Done? Yeah. Then continuing. The universal gravity. Yeah, that is done. This page is done. Yeah, dimensional formula. You should know the dimensional formula. G is equal to what? Fr square by m1 m2. Force dimensional formula is what? ml t raised to minus 2 into distance is what? L square divided by m into m. So what happens? M gets cancelled. M raised to minus 1 L cube t raised to minus 2. This is the dimensional formula for G. M raised to minus 1 L cube t raised to minus 2. This is the dimensional formula for G. Universal gravitation constant dimensional formula m raised to minus 1 L cube t raised to minus 2. So that is done. Next, important features of gravitational force. അത് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. പേര് പറയണ പോലെ തന്നെ വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. ലെറ്റ്സ് സീ. Gravitational force between two masses is independent of intervening medium. See, two bodies masses of m1 m2 separated by a certain distance. the force between them is the same whether they are in water, air, kerosene. Gravitational force does not depend on the intervening medium. Gravitational force between two point masses is a central force. It acts, see, when you consider gravitational force, some students draw figures like this. This is wrong because it acts from center of a body to center of the other mass. Suppose this is M1 and M2, it has central force. It acts from center of one body to center of another body. It is having spherical symmetry. See, when I take class, I always take class facing the student. So my class is having angular symmetry. But what is anyway spherical symmetry? In all direction within a radius, the force is same. See, in this radius, gravitational force between me and some other particle in this radius will be same. It is having what symmetry? Spherical symmetry. That means in all direction, gravitational force will be same. Thus, a gravitational force possesses spherical symmetry. Gravitational force is a conservative force. What are the properties of conservative force? Work done independent of path. Work done independent of path. Then work done depends on what? Work done depends on displacement. Work done for a rounded trapeze. Work done for a rounded trapeze 0. Then work done completely recoverable. That we have explained in the work energy power chapter. Work done completely recoverable. These are the features of gravitational force. And one more feature, gravitational force between two bodies is independent of the presence of other bodies. Suppose there is a mass m1 and there is a mass m2. Gravitational force between m1 and m2 does not depend. Suppose there is m3 is there, m4 is there. Even if m3, m4 are present or absent, the gravitational force between m1 and m2 will be the same. Gravitational force between M1 and M2 does not depend on the presence of other bodies. Any doubt? Manasilayo? These are the features of gravitational force. Doubt unda? Note ചെയ്യട്ടാ. നോട്ട് ചെയ്യട്ടോ. കഴിഞ്ഞോ? നോട്ട് ചെയ്ത് കഴിഞ്ഞോ? All of you finish? Listen, these features are very important for entrance. They will, you can expect question like choose the right statement, choose the wrong statement, in that way. In entrance, you can expect question like choose the right statement, choose the wrong statement. Done? So next topic, relation between G and G. Okay, let me derive that. See, suppose this is heading relation between acceleration due to gravity small letter g and universal gravitation constant capital letter G. See, this is a sphere, there is a mass m, this is the mass of the earth. So G is equal to, what is the force on this mass? F equal to ma, but this acceleration is acceleration due to gravity, so F equal to mg. For same force F, we have gmm by r square. What is r? The distance between two bodies, which is the radius of the earth. So this is equation 1, this is equation 2. Comparing equation 1 and 2, we get mg is equal to what? gmm by r square. So what happens? Mm gets cancelled. G is equal to what? Gm by r square. So G is equal to 6.67 into 10 raised to minus 11 into mass of the earth 5.98 into 10 raised to 24. Some teachers write it at 6. And radius of the earth is 6.4 into 10 raised to 6. Remember, radius of earth is 6,400 kilometer or 6.4 into 10 raised to 6 meter. If you substitute all the values, then you will get what? G equal to 9.8 meter per second square. Now you should remember this equation, G is equal to Gm by r square. That is the relation between small letter g and capital letter G. Small letter g is equal to Gm by r square. Note here. നോട്ട് ചെയ്താ? നോട്ട് ചെയ്താ? പ്രദീപ് ലക്ഷ്മൺ നോട്ട് ചെയ്ത് കഴിഞ്ഞു. വാട്ട് അബൌട്ട് others? Have you guys finished? Done. Next, variation of G with shape of earth. G with shape of earth. ഇതെന്താ വെച്ചാലേ ശ്രദ്ധിക്കുക, എർത്ത് ഈസ് നോട്ട് എ പെർഫെക്റ്റ് സ്ഫിയർ. എർത്ത് എന്തല്ല? ഒരു പെർഫെക്റ്റ് സ്ഫിയർ അല്ല. ശ്രദ്ധിക്കുക, equatorial radius is greater than polar radius by 21 kilometer. Suppose this is earth, this is equatorial radius, this is polar radius. So equatorial radius greater than polar radius by an amount what? 21 kilometer. So G is equal to what? Gm by r square, which is a standard formula. So gravity at the equator means what? Gm by equatorial radius square. What is this equatorial radius? Distance from the what is equatorial radius? This is equator, this is poles. So equatorial radius is greater, so gravity at equator will be what? Lesser. We know that weight equal to mass into gravity. When gravity at equator becomes lesser, weight at equator also becomes lesser. In the lower classes, you have studied about time period of simple pendulum. Time period of simple pendulum. What is equation for time period of simple pendulum? T equal to 2 pi root L by G. Now gravity at equator is what? Lesser. So time period at equator will be what? Greater. Now frequency is what? Reciprocal of time period. Frequency denoted by letter nu. ഇതിനെങ്ങനെയാ വായിക്കുക? Nu എന്നാണ് വായിക്കുക. Nu equal to 1 by T ആണ്. Time period at equator is greater. That means what? Frequency at equator will be lesser. Now similar way, G is equal to Gm by r suffix p square. Polar radius is what? Lesser. So gravity at poles will be what? Greater. So weight equal to what? Mass into gravity at poles. Gravity at poles increases, weight at poles also increases. Weight at poles also increases. So time period equal to what? 2 pi root L by G. Now gravity at poles is greater means what? Time period at poles will be what? Lesser. If time period at poles lesser, then frequency at poles will be what? Greater. Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? ഈ കോൺസെപ്റ്റിലെ ഡൗട്ട് ഉണ്ട്. എന്തുകൊണ്ട് ഇങ്ങനെ ഒരു ചെറിയ വേരിയേഷൻ വരാൻ കാരണം, എർത്ത് ഈസ് നോട്ട് എ പെർഫെക്റ്റ് സ്ഫിയർ. എർത്തിന് കോഴിമുട്ടയുടെ ഷേപ്പാ. ഇക്വേറ്ററിലേക്ക് ഡിസ്റ്റൻസ് കൂടുതലും പോൾസിക്ക് ഡിസ്റ്റൻസ് കുറവാണ്. ദാറ്റ് ഡിഫറൻസ് ഈസ് സ്മോൾ ഓൺലി 21 കിലോമീറ്റർ. ഡൗട്ട് ഉണ്ടോ? So what happens? Weight is what? Minimum at equator, maximum at poles. So I should write the weight of a body increases as it is brought from equator to poles. Brought from equator to poles. As it is brought from equator to poles. As it is brought from equator to poles. ഇതിൽ ഡൗട്ട് വല്ലതും ഉണ്ടോ മക്കളെ? നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? അപ്പോൾ വെയിറ്റ് ഓഫ് എ ബോഡി ഇൻക്രീസസ് as it is brought from equator to poles. Maximum weight of a body at poles, minimum weight at equator. I will add that line. Maximum gravity and maximum weight at equator, say at poles, minimum gravity and minimum weight at equator. Minimum weight at equator. Now, I will give you an example. Suppose I am a smuggler who smuggles goods. I am taking 1 gram of diamond from poles to equator. So at equator, it weighs only 995 milligram. 0.005 milligram, 0.005 gram, 0.005 gram difference will be there. And just giving you an example, will be there. Why there is a difference of 0.005 gram difference? Because G is not a constant, G is minimum at the equator. So due to lesser G, the weight will be lesser at equator. But the change is very small, only 0.005 gram change means what? A very, very small change. But since I am bringing diamond, even that small change is significant. So you have to adjust that weight change. Time period ഒന്നും കൂടി പറയുമോ മോനെ? ടൈം പീരീഡ് ഓഫ് എ സിമ്പിൾ പെൻഡലം എന്ന് പറയണതേ, ടൈം പീരീഡ് ഓഫ് എ സിമ്പിൾ പെൻഡലം എന്ന് പറഞ്ഞാൽ ഇതാണ് ഒരു സിമ്പിൾ പെൻഡലം, ഒരു പെൻഡുലം. ഇതാണ് സിമ്പിൾ പെൻഡലം. ഇതിങ്ങനെ ഇട്ട് കഴിഞ്ഞാൽ സ്വിങ് ചെയ്യും. ഇതിന്റെ ടൈം പീരീഡിന്റെ ഇക്വേഷൻ ബൈ ഹാർട്ട് ചെയ്യുക. അത് വേറെ ചാപ്റ്ററിൽ ഡീറ്റെയിൽ ആയിട്ട് എടുക്കുന്നുണ്ട്. 2π√L/G. ഇതാണ് ബോബ് എന്ന് പറഞ്ഞാൽ ഉണ്ട. ഈ ഉണ്ടാണ് ബോബ്, അതിന്റെ ലെങ്ത് ആണ് L. അപ്പൊ ടൈം പീരീഡ് ഓഫ് സിമ്പിൾ പെൻഡലത്തിന്റെ ഇക്വേഷൻ ആണ് 2π√L/G. ഈ ഇക്വേഷൻ ആരെ ഡിപ്പെൻഡ് ചെയ്യുന്നുണ്ട്? ഗ്രാവിറ്റിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നുണ്ട്. ഈ ഇക്വേഷൻ ചെറിയ ക്ലാസ്സുകളിൽ കുട്ടികൾ പഠിക്കുമ്പോൾ G കോൺസ്റ്റന്റാ. പക്ഷെ ഇപ്പൊ നമുക്കറിയാം G കോൺസ്റ്റന്റ് അല്ല. ഇക്വേറ്ററിൽ ജിയുടെ വാല്യൂ കുറവാ. അപ്പൊ ടൈം പീരീഡ് ഇക്വേറ്റർ എന്താവും? കുറയും. ഈ ഇക്വേഷൻ കണ്ടപ്പോൾ നിങ്ങൾക്ക് ഒരു കാര്യം മനസ്സിലായോ? വളരെ ഇമ്പോർട്ടന്റ് ആയിട്ടുള്ള ഒരു പോയിന്റ് ഉണ്ട്. ഡൗട്ട് ചോദിച്ചുകൊണ്ട് പറയാണ്. ടൈം പീരീഡ് ഓഫ് സിമ്പിൾ പെൻഡലം is independent of amplitude of oscillation and mass of the bob. ഇത് വളരെ ഇമ്പോർട്ടന്റ് ആയിട്ടുള്ള ഒരു പോയിന്റാ. ടൈം പീരീഡ് ഓഫ് സിമ്പിൾ പെൻഡലം ആരെ ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല? ആംപ്ലിറ്റ്യൂഡ് ഓഫ് ഓസിലേഷനെ ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല, മാസ് ഓഫ് ദ ബോബിനെയും ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല. അതായത് എത്ര നിങ്ങൾ 1 കിലോ ഭാരമുള്ള ബോബ് ആട്ടിയാലും 1000 കിലോ ഭാരമുള്ള 1000 kg ഭാരമുള്ള ബോബ് ആട്ടിയാലും ടൈം പീരീഡ് എന്താ സെയിം ആ. ബിക്കോസ് ഇറ്റ് ഈസ് ഇൻഡിപെൻഡന്റ് ഓഫ് ആംപ്ലിറ്റ്യൂഡ് ഓഫ് ഓസിലേഷൻ. ആംപ്ലിറ്റ്യൂഡ് എന്ന് പറഞ്ഞാൽ ഈ കറങ്ങണത്, ഈ ഡിസ്റ്റൻസ് ആണ് ആംപ്ലിറ്റ്യൂഡ്. അതിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല. ടൈം പീരീഡ് ആകെ ഡിപ്പെൻഡ് ചെയ്യുന്ന ലെങ്ത്തിനും ഗ്രാവിറ്റിനെയാണ്. ഈ ഗ്രാവിറ്റി ഇക്വേറ്ററിൽ കുറവാ. അപ്പൊ ടൈം പീരീഡ് ഇതിലൊരു മിസ്റ്റേക്ക് ഉണ്ടല്ലോ. ഗ്രാവിറ്റി ഇക്വേറ്റർ ലെസ് ആണ്. അപ്പൊ ടൈം പീരീഡ് എന്താവും? ടൈം പീരീഡ് കൂടും. ഗ്രാവിറ്റി ഇക്വേറ്റർ ലെസ് ആണ്. അപ്പൊ ടൈം പീരീഡ് കൂടും. എന്നാ പോളാർ റീജിയനില ഇക്വേഷൻ സെയിം ആണ്. ഗ്രാവിറ്റി പോൾസ് എന്താ? കൂടുതലാണ്. അപ്പൊ ടൈം പീരീഡ് അറ്റ് പോൾസ് എന്താവും? കുറയും. ഡൗട്ട് ഉണ്ടോ? പ്രദീപ് ലക്ഷ്മൺ ഐഡിയിലുള്ളവർക്ക് ഡൗട്ട് ഉണ്ടോ? 1 gram മാസ് അല്ലേ? എവിടെ 1 gram മാസ്? പ്രദീപ് ലക്ഷ്മൺ ഡൗട്ട് ഉണ്ടോ? ഇനി ടൈം പീരീഡിന്റെ റെസിപ്രോക്കലാണ് ഫ്രീക്വൻസി. അപ്പൊ ടൈം പീരീഡ് അറ്റ് ഇക്വേറ്റർ എന്താ? അത് കൂടുതലാണ്. അപ്പൊ ഫ്രീക്വൻസി അറ്റ് ഇക്വേറ്റർ എന്താവും? കുറയും. പിന്നെ ടൈം പീരീഡ് അറ്റ് പോൾസ് എന്താ? കുറവാണ്. അപ്പൊ ഫ്രീക്വൻസി അറ്റ് പോൾസ് എന്താ? കൂടും. ഡൗട്ട് ഉണ്ടോ? അപ്പൊ ടൈം പീരീഡ് ഓഫ് സിമ്പിൾ പെൻഡലം ആർക്ക് ഇൻഡിപെൻഡന്റ്? മാസ് ഓഫ് ദ ബോബിന് ഇൻഡിപെൻഡന്റ് ആണ്. ആംപ്ലിറ്റ്യൂഡ് ഓഫ് ഓസിലേഷനും ഇൻഡിപെൻഡന്റ് ആണ്. ഫോർ എക്സാമ്പിൾ ഇത് നോട്ട് ചെയ്തില്ലേ? ഇത് നോട്ട് ചെയ്തില്ലേ? ഈ 2 പോയിന്റ് നോട്ട് ചെയ്തോളൂട്ടോ. വൺ ഗ്രാം മാസ് ഡയമണ്ട് എക്സാമ്പിൾ. ഓക്കെ, 1 gram mass diamond എന്താ? 1 gram of diamond from poles to equator. At equator it weighs 995 milligram. അപ്പോൾ there is a shortage of 0.005 gram. അതിൽ എന്താ പ്രശ്നം? ഹർഷ, what is your problem? What is your doubt? I didn't get you. 1 gram mass അല്ലേ? അതെ, 1 gram. അതായത് നീ പറഞ്ഞത് 1 gram മാസ് ആണ്. മാസ് ഒരു കോൺസ്റ്റന്റ് ആണ്. ഞാൻ ഉദ്ദേശിച്ചത് അതല്ല. ഇഫ് ഈ വെയ് ചെയ്യുമ്പോ അത് അതിന്റെ മാസിൽ കുറവ് വരുന്നല്ല ഉദ്ദേശിച്ചത്. അത് നീ പറഞ്ഞ കറക്റ്റാ. ഹർഷ വാസ് സെയിങ് ദാറ്റ് mass is constant, but when I weigh that, there is a reduction in weight. Actually it should be ഇവിടെ 1 gram mass, 1 gram of diamond, 1 gram of diamond is weighed at what? Poles. Then it is weighed at equator. So when you weigh that, there is a difference in weight. But ഞാൻ എഴുതിയത് മാസിലെ ഡിഫറൻസ് ആണ്. വെയിറ്റ് എന്ന് ഇവിടെ എഴുതിയിട്ടുണ്ട്. അത് ഇവിടെയും കൂടി സ്പെസിഫൈ, ഇറ്റ് ഷുഡ് ഹാവ് സ്പെസിഫൈഡ് ഹിയർ ഓൾസോ. There should be no difference in mass, but weight will be what? 1 gram into what? 9.8 Newton. Here it should be what? Instead of 9.8 here, the gravity will be lesser. So it will have less weight. What Harsha was saying that, sir, sir had written that 1 gram of mass, but actually 1 gram of mass weighed at the poles. That weight will be lesser when you weigh the same diamond at equator. Why? What is the reason behind that? At equator, gravity will be lesser and weight is equal to mass into gravity. Mass does not change, but weight will be lesser at equator. Clear, right? Yeah. Arsha, what you said is right only. Mass remains the same, but the weight value that you get when you weigh at poles and weigh at equator will be different. At the poles, you will have large weight. At equator, you will have less weight. Next year, or next is a very lengthy derivation. Variation of G with height. Variation of G with height. That is our next derivation. So this is Earth. This is radius of the Earth. There is a mass at the surface of Earth. Then at a height h. So gravity at G, same mass is brought to this height. Gravity at suffix h. What is G? Gravity on the surface. What is GH? Gravity at a height h. So G is equal to what? Gm by r square. Gravity at a height means what? Your Earth will be having this much radius. So what is gravity at a height? Gm by r plus h the whole square. Why Gm by r plus h? If the body is at this much height, the distance from that body to the center of the Earth will be what? R plus h. So that is the reason why instead of Gm by r square, I have taken Gm by r plus h the whole square. I hope it is clear. മനസ്സിലായോ? ഇത്രയും പോയിന്റ് മനസ്സിലായ? സർഫസിലെ ഗ്രാവിറ്റിയാണ് ജി, അറ്റ് ഹൈറ്റ് എച്ചിലെ ഗ്രാവിറ്റിയാണ് എന്ത്? ജി എച്ച്. ഡൗട്ട് ഉണ്ടോ? ഡൗട്ട് ഉണ്ടോ? So what is GH by G? What is GH by G? GH by G is equal to GM by R plus H the whole square divided by GM by R square. So instead of GH I have taken this equation. Instead of G I have taken this equation. So let's continue. GH by G is equal to GM by R plus H the whole square into R square by GM. So GM gets cancelled. GH by G is equal to R square by R plus H the whole square. So GH by G is equal to R square by when you expand this, R square plus 2RH plus H square. Now see the next step. Next step will be confusing for some of the students. See GH by G. Numerator is R square only. From the denominator, I am taking R square common. So instead of R square, what we have? 1 plus 2RH by R square by H square by R square. So what you are doing? We are taking R square common. So if you are having doubt, please take R square inside. So R square into 1 R square into 2RH by R square 2RH, R square into H square by R square, H square only. So this, why I am doing that? Because I can cancel these two R square. So GH by G is equal to what? 1 by 1 plus H by R the whole square. Any doubt? GH by G is equal to what? 1 plus H by R the whole square. So GH by G is equal to what? 1 plus H by R whole raised to minus 2. So GH by G is equal to what? 1 plus H by R whole raised to minus 2. Remember, if you expand 1 plus H by R whole raised to minus 2 using binomial theorem, we get 1 minus 2H by R. What we get? 1 minus 2H by R. If you expand 1 plus H by R whole raised to minus 2 using binomial theorem, what do you get? 1 minus 2H by R. So GH by G is equal to what? 1 minus 2H by R. So what is GH? G into 1 minus 2H by R. See, what is the step of this binomial theorem expansion? That is not required in your syllabus. Just simply understand that if you expand 1 plus H by R whole raised to minus 2, you will get 1 minus 2H by R. So what is the equation for gravity at height? G into 1 minus 2H by R. This equation should be used if H is less than 100 kilometer. Now GH is equal to, GH by G is equal to R square by R plus H whole square. That is one more equation. This equation should be used if H is unknown, or H greater than 100 kilometer. Then only you should use the second equation. I hope it is clear. It's a very, very important derivation. വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഡെറിവേഷൻ ആണ് വേരിയേഷൻ ഓഫ് ജി വിത്ത് ഹൈറ്റ്. നോട്ട് ചെയ്യട്ടോ, വേരിയേഷൻ ഓഫ് ജി വിത്ത് ഹൈറ്റ്. കഴിഞ്ഞോ? All of you done? Finish? Next, variation of G with depth D, with depth. Now listen, ഇത് എർത്ത്, സർഫസിലെ ഗ്രാവിറ്റി G, അതിൽ നിന്ന് ഡി ഡെപ്തിലെത്തി, അവിടുത്തെ ഗ്രാവിറ്റി G സഫിക്സ് D. ഈ വോൾ ഡിസ്റ്റൻസ്, റേഡിയസ്, this much distance R minus D. I hope it is clear. See, gravity at the surface G, I have made a depth of D, or kuri kurichu of depth D. Then I am reaching at this point. At this point, gravity is G suffix D. Why the gravity is lesser? Because when I reach this point, my actual Earth will be only this much. So what is the radius of Earth when I reach this point? It is R minus D. What is the original radius? R. I hope it is clear. Now let's start the derivation. Density equal to, what is the formula for density? Mass by volume. So mass is equal to, what is the formula? Volume into density. So mass m is equal to volume 4 by 3 pi r cube, density rho. Mass equal to what? Volume 4 by 3 pi r cube into density rho. So G is equal to what? Gm by r square. So G is equal to G into, instead of m, I can write 4 by 3 pi r cube by r square. So what I will be getting? 4 by 3 pi g r rho. Students, please remember this equation for gravity in terms of density. What is this? Rho. It is called, pronounced as rho, which stands for density. Volume is 4 by 3 pi r cube. We will be considering Earth as a sphere in this case. So what is the equation for acceleration due to gravity? 4 by 3 pi g r rho. So gravity at a depth means what? Gravity at a depth means 4 by 3 pi g, which is a constant. If I am at a depth d, then my radius is what? R minus d into rho. Divided by g is what? 4 by 3 pi g r rho. 4 by 3 pi, 4 by 3 pi g rho, everything gone. So GD by G is equal to what? R minus D by R. So GD by G is equal to what? R by R minus D by R. So GD by G is equal to what? 1 minus D by R. So gravity at a depth is equal to what? G into 1 minus D by R. This is the equation for gravity at a depth. G into 1 minus എത്ര ആഴത്തിൽ കുഴിച്ചു divided by radius of the earth. This is the equation for gravity at a depth. നോട്ട് ചെയ്തെല്ലാവരും. നെക്സ്റ്റ്, relation between gravity at a depth and gravity at a height. Very simple relation, d equal to 2h or h equal to d by 2. We will do one example question. At what height above Earth's surface, gravity becomes half. Gravity becomes half. At what height above the Earth's surface, gravity becomes half. GH is equal to, what height above the Earth's surface gravity becomes half. I have two equations for gravity. GH by G is equal to R square by R plus S the whole square. And the second equation is GH equal to G into 1 minus 2H by R. But this equation I should not be using, because this equation should be used when height is less than 100 kilometer. So I should go for this equation. Why? Because when height is unknown, I should use this equation. So what is this equation? GH by G is equal to, it is given that gravity becomes half. So GH is equal to what? G by 2. So G by 2 by G is equal to what? R square by R plus H the whole square, because it is given that GH equal to G by 2. That means G by 2G is equal to what? R square by R plus H the whole square. That means G gone. 1 by 2 is equal to what? R square by R plus H the whole square. So R plus H, R by R plus H is equal to what? R by R plus H is equal to what? 1 root 1 by 2. So that means R by R plus H is equal to 1 by root 2. So root 2R is equal to what? R plus H. So H is equal to what? Root 2R minus R. So H is equal to root 2 into, if you take R common, R into root 2 minus 1. So H is equal to R into 1.414 minus 1. So H is equal to R into 0.414. We know that R equal to what? 6,400 kilometer into 0.414. This calculation you should do. Then you have to type your answer. That much kilometer. Any doubt? Any doubt? ചെയ്തതിലെ ഡൗട്ട് ഉണ്ടോ? At what height gravity becomes half? സോൾവ് ചെയ്തിട്ട് എന്നിട്ട് ആൻസർ പറയും. If you solve that, your answer will be 2649.6 kilometer. 2649.6 kilometer. Kanya. Next, noted. Okay. Next, I'm doing one question here. At what height above the earth surface, gravity will be same as gravity at 50 kilometer depth, or you can say, or below the earth surface. So what is the meaning of this question? At a 50 kilometer below the earth surface, there is a particular gravity. To get the same gravity, how much high you should go above the earth surface? See, at a depth of 50 kilometer, there is a gravity. G is always D. To get the same gravity, how much high should go? Remember, D equal to 2h. So h equal to what? D by 2. So what is answer? 50 by 2. Answer is what? 25 kilometer. മനസ്സിലായോ? കഴിഞ്ഞോ? നോട്ട് ചെയ്തോ? ഇനി Gravity at center of Earth. At center of Earth. Now listen. Suppose I am digging a hole to the center of the Earth such that depth equal to radius. So gravity at the center is equal to what? G into G is equal to gravity at depth is equal to G into 1 minus d by R. 1 minus d by R. Gravity at the center means what? G into 1 minus R by R. So gravity at the center is equal to what? Gravity on the surface into 1 minus 1. So gravity at the center is equal to what? 0. So what will be the weight at the center? Mass into gravity at the center. If weight at the center is equal to 0, sorry, gravity at the center equal to 0 means what? Weight of a body at the center of the earth will be what? 0. Weight of a body at the center of the earth will be 0. Thus, a person experience weightlessness at the center of the earth. Weightlessness at the center of earth. A person experience what? Weightlessness at the center of the earth. A person experience weightlessness at the center of the earth. Any doubt? ഡൗട്ട് ഉണ്ടോ മക്കളെ? ഡൗട്ട് ഉണ്ടോ? അപ്പോൾ സെന്റർ ഓഫ് ദ എർത്തിൽ പേഴ്സൺ എക്സ്പീരിയൻസ് വാട്ട്? വെയ്റ്റ്ലെസ്നെസ്. നമ്മൾ മുമ്പ് പഠിച്ചു ലിഫ്റ്റ് താഴത്തോട്ട് വീഴുമ്പോഴും പേഴ്സൺ എക്സ്പീരിയൻസ് വാട്ട്? വെയ്റ്റ്ലെസ്നെസ്. ട്ടാ നോട്ട് ചെയ്തോ? നോട്ട് ചെയ്യട്ടോ എല്ലാവരും. അപ്പൊ മക്കളെ ഞാൻ അവിടെ സ്റ്റോപ്പ് ചെയ്യാണ്. എഴുതിയെടുക്കുക, എന്നിട്ട് പോവാ കേട്ടോ. നെക്സ്റ്റ് ക്ലാസ്സിൽ നമ്മൾ അഗെയിൻ ഗ്രാവിറ്റേഷൻ കണ്ടിന്യൂ ചെയ്യും. സോ താങ്ക് യു സ്റ്റുഡൻസ്, താങ്ക് യു, ഗുഡ് നൈറ്റ്.